So hello everyone, today we are going to see the introduction to the data link layer. So let's start. You can see that on the screen there are different networks which are connected to each other. Okay, what is network? Network is a collection of more than one devices. So you can see that there are different networks. There is a mobile network, then there is a global ISP, there is a data center network. These all individual networks are connected to each other. Okay, now suppose the device which is present in your home, suppose let's say this is device A, wants to send some data to the device present in the another network, let's say device B. So when device A sends any data, the data will be passed to the nearest router, the router in your home. Then it will be forwarded to the next router. Then the router will decide that what is the best path to deliver the received data. After deciding, it will forward the data, and after some time the data will be delivered to device B. So this is the basic flow of the data when sender sends any data and when receiver is receiving data. Now, what is the responsibility of the data link layer? The responsibility of the data link layer is to transfer the data from one node to adjacent node only. What I am trying to say is, when this router forwards the data to the next router, the responsibility of the data link layer completes. So the responsibility of the data link layer is to transfer data from the one node to adjacent node only. Okay, so you can see that the link layer has a responsibility of the transferring datagram from one node to physical adjacent node over a link. Now let's see the other responsibilities of the data link layer. The first one is the framing. So you can see that in this figure there are four devices. Device A, B, C and D are connected to each other. Suppose device A is sending data to device B and C at the same time. Suppose A is sending data which is 10110 to B, and A is sending data to C which is 1110, and the stream of bits will be sent to both devices. Now you can see that device B and C will receive this stream of bits. Now in this stream of bits, the 10110 is the data for one device and 1110 is the data for another device. But because there is nothing is there in the stream of bits, device B and C won't be able to know that what is the starting of the data that they should receive and what is the end of the same data. Are you getting it? Device B is getting confused. Device B is not able to understand that from where it has to start receiving the data until where it has to stop receiving the data. And the same problem is present for device C too. So what I'm trying to say is, when device A is sending any frame, before sending frame it will add some extra data using which the receiver will be able to know that okay, this is the start of the frame and this is the end of the frame, and that thing is known as framing. We are going to discuss different framing methods when we will discuss this topic in detail. Now let's see the remaining responsibilities. The first one is the flow control. Then there is a error detection, error correction and the multiple access protocol. Let's see these responsibilities in brief. So what is the meaning of the flow control? Suppose this is device A and this is device B. A is sending data at 10 Mbps and B is able to receive data at 5 Mbps. So it means that A is sending data at very high rate, but B is not able to receive data at that rate. So what will happen? Obviously there will be the loss of data, because A is sending data at 10 Mbps, which is very high, but B is not able to receive data at that speed. So what is the meaning of flow control? Flow control means device A or sender should be sending data at the rate at which the receiver is able to receive. If sender sends data at 5 Mbps, in that case there will be no problem. So it is a responsibility of the data link layer to send data at particular rate so that the sender and receiver can communicate properly. The next one is the error detection. Now suppose A is sending data which is 1011 and 1011 is sent to B. Now because there is some noise is present in the link, the data which is sent by A is changed from 1011 to 1010. So the B is receiving 1010 because of the noise which is present on the link. Now you can clearly understand that the value of the data is changed, and if only one bit is changed, in that case the whole data can get corrupted. So what I'm trying to say is there should be something which is present at the receiver side, there should be something which is present at the device B that it can understand that the received data contains any error or not. The receiver should be detect error, and that is known as error detection. There are many methods available for the error detection that we will discuss in the detail, but right now we are discussing the brief introduction or the brief of each and every responsibility of the data link layer. So error detection means that receiver should be able to detect the error if there is present in the data. The next one is the error correction. Like if receiver detects any error, the receiver is also able to correct the error. There are many methods available using which the receiver can correct error, and which is known as error correction. Now let's see the next responsibilities, which is multiple access protocols. You can see that in this figure, these 5 devices are connected using the same channel. Now if more than 2 devices are connected to same channel, there is a high possibility that there will be the collision in the network. Now what is the meaning of collision? Collision means that when 2 devices are sending data at the same time, the data will be collided in the network and it will create the collision. So to avoid the collision, there should be some multiple access protocols which are required. Okay, and we will discuss this multiple access protocol in the detail. Now the question is where the link layer is implemented. The link layer is implemented in each and every host. Generally in your laptop there is a network interface card in which the data link layer is implemented. Okay, the data link layer is also implemented in different circuits such as Ethernet card or Wi-Fi card or chip. And the data link layer, it is a combination of the hardware and software. Okay, so we will see that the data link layer is not only present at the hardware layer, it is also present at the software layer. So data link layer, it is a combination of the hardware and the software. So you can see that there is a one computer. Now you guys know that in each and every computer there are main 5 layers. There is a physical layer, data link layer, network layer, transport layer, and the application layer. Now these first 3 layers, network, transport, and the application layer, are present in the CPU. Means these 3 layers are implemented at the software layer, but the data link layer is implemented in the software as well as hardware. So you can see that it is a network interface, this portion is circuit. So data link layer is present, the data link layer is present at the hardware layer, it means in the circuit, as well as in the software layer, it means in the ports. So the data link layer is a combination of the hardware and the software. Now this is one example that what happens when one device sends data to device B. There is a device A, and device A contains these 5 layers. There is a application layer, transport layer, network layer, data link layer, and the physical layer. Device B contains again 5 layers: application layer, transport, network, data link, and the physical layer. Now the packet which is present in the network layer, it will be passed to the data link layer. You can see that network is passed to the data link layer and it is encapsulated in the frame. Now this frame will be forwarded to the receiver, and at the data link layer present at the receiver side, it will see the information which is present in the frame, and this frame will be forwarded to the network layer. So when the data is received from the upper layer, from the network layer to the data link layer, in the data link layer the data will be encapsulated in the frame, and that frame will be sent to the receiver. When receiver receives the frame, at the same layer, at the data link layer, that frame will be removed and data will be passed to the upper layer, which is network layer. Now let's see the frame format of the data link layer. You can see that in the frame format there are different fields such as the preamble, then there is a start frame delimiter, then there is a destination address, source address, length, data and padding, and the CRC. Let's see each and every field one by one. The first one is the preamble. The size of the preamble is 7 bytes. The preamble is used to synchronize the receiver, and the value of the preamble is continuous 1 and 0 for 7 bytes. So it is continuous 1 and 0 for 7 bytes. So when receiver receives continuous 1010, it can understand that this frame is preamble. The next one is the start frame delimiter. The size of the start frame delimiter is 1 byte. Now what is the purpose of the start frame delimiter? You can say that the value of the start frame delimiter is the same as the preamble, but the last 2 bits are 1 1. So when the receiver encounters these 2 bits, when the receiver encounters this 2 1, receiver will understand that okay, this is the start of the destination address field. Now in the destination address there will be the destination MAC address, okay, the 6 byte of destination MAC address. In the source there will be the 6 byte of the source MAC address. There is a length or type, like which type of data is present in the frame. The next field is the data and padding. We just saw that when the data is received from the upper layer, it will be encapsulated in the frame, in the data and padding. And the last one is the CRC. The size of the CRC is 4 bytes and it is used for cyclic redundancy check. Now let's see what is the MAC address. This is the example of the MAC address. The MAC address, it is a 48-bit address and it is represented by colon hexadecimal. What is the meaning of colon hexadecimal? Colon hexadecimal means that each number is separated by colon and each number is represented in the hexadecimal. So in the hexadecimal, 1 digit, if we convert this 1 digit in the binary, we will get 4 bits. So you can see that total 12 hex digit and 12 into 4, it means 48 bit, which is the length of the MAC address. Now there are totally 3 type of MAC address: unicast, multicast and the broadcast. What is unicast? Unicast means 1 to 1. What is multicast? Multicast means 1 to many. So A can send data to multiple devices. And broadcast, it means 1 to all the devices which are present in the network. And you can find the unicast, multicast and the broadcast MAC address by seeing the MAC address only. How you can find that? Let's see. So in the first byte of the MAC address, if last bit is 0, it means the network is unicast. If the last bit is 1, it means the address is multicast. If in the MAC address all the bits are 1, it means that MAC address is the multicast MAC address. And this is the MAC address. You have to find that whether it is a multicast, unicast or broadcast. And this is it for this session. Thank you so much.